Hi all, hope you all are doing good. From today onwards, we are going to see a lecture series on the subject Design and Analysis of Algorithm. Please note down the course code. It is 19 ITB 201. B represents blender, so it is a blended course. So first unit is Introduction to Algorithms. Hi, now we are going to see about how to analyze the algorithms and its time efficiency in terms of non-recursive algorithms. Here we are going to consider only the non-recursive algorithms uh, and analyze its time efficiency. For recursive algorithms, the time efficiency calculation or the analyzing will be different. So we'll consider first the non-recursive algorithms and we can proceed towards the recursive algorithms. This is the general plan for analyzing the time efficiency of non-recursive algorithms. The first step is we have to decide on a parameter or parameters indicating an input size. The first and foremost step is we have to find the input size of the algorithm. Next, second step is identify the algorithm's basic operation. As a rule, it is located in the innermost loop. The operation which is located in the innermost loop can be considered as the basic operation, or the code or statement which contributes more towards the algorithm's working is also can be called as basic operation. The third step is we have to check whether the number of times the basic operation is executed. In this third step we have to find how many times that basic operation is going to execute in the whole program. So that depends upon the size of an input. It also depends on some additional property, the worst case, average case, and if necessary best case efficiencies have to be investigated separately. Then fourth step, setting up a sum expressing the number of times the algorithm's basic operation is executed. The fifth step is with the help of standard formulas and rules of sum manipulation, you can find the closed form formula for the count, or at the very least establish its order of growth. This is the formula for sum manipulation. Please make a note of it. Here we are going to see about the element uniqueness problem. The element uniqueness problem means we have to find whether the given elements in the array are unique. We have to say that this array is unique if the array contains elements which everything is unique. Okay, here in the given example we are going to use 7 elements, so your n, the number of elements is 7, so n minus 1 is 6, n minus 2 is 5. So this n minus 1, n minus 2 indicates the index, is used to calculate the index of the array. So our algorithm is unique elements of a of 0 to n minus 1. This 0 to n minus 1 indicates the index position of the elements. So here we are going to determine whether all the elements in the given array are distinct. So what is the input to this algorithm is an array a of 0 to n minus 1. The output is it returns true if all the elements in a are distinct and false otherwise. So here we are going to use the two for loops. For I is equal to 0 to n minus 2 do, for j is equal to I plus 1 to n minus 1 do. The purpose of using this for loop is we have to compare each and every element with the other element, but not the same element with again the same element. So we are using two for loops. So the condition is if a of I is equal to a of j, we have to return false, that is the given arrays in the given elements in the array are not distinct, else we have to return true. So this is the algorithm to find whether the element is unique in the given array. So this is the element uniqueness problems analysis. So according to the general plan, the first step is we have to find the problem size. So here the problem size is n. So what do you mean by n is the number of elements in the array. So what is the basic operation is the basic operation here is the if statement, that is the comparison. So according to the general plan, the condition in the innermost loop will be the basic operation. So according to this element uniqueness problem, the innermost loop is if statement, that is comparison, so that will be the basic operation. Next one, the count of basic operation. The count of basic operation is summation of I is equal to 0 to n minus 2 and summation of j is equal to I plus 1 n minus 1 into 1. So what are these limits above the summation, or the limits in the for loop? For loop starting and ending condition represents the upper limit and lower limit of the summation. Next, it depends upon what efficiency. So in worst case, all the elements are different, all sequence of for loop. Suppose if the same elements or similar elements is found at the last of the array, we have to process all the elements and we have to find it. So that's the worst case. If the best case is if the first two elements of the array are not unique. For example, the first two elements are 10, so first element is 10 and the next element is also 10. That itself a condition fails and it comes out of the loop. So that is the best case. So summation on solving the above equation, we get time complexity as big O of n square, and that is the time complexity of element uniqueness problem.